Okay, this is a demo of Saracen. This is basically one of my IDE that I built to do my programming. This was a pretty old project. I stopped developing in 2012. I suffered a accident, and then by the time I came out, it was already a couple of years late. So I just dumped the whole source code here. You can go and access it. It's pretty old source code. The project is in Eclipse. It's supposed to be run as a web IDE on your local machine. And the idea behind this was I used to use it to run it on iPad and other stuff. And it's a visual programming environment. So when you take it out, when you take out the code and run it, you can run it in the Eclipse. What you will see is you will be visited by a this page. So to start this page, to give you an overall overview of it, it is basically a visual programming environment, and it has a lot of stuff. If you look at the code, it has a lot of facilities, and apart from that, it has a plugins. I have not exported the plugins because a lot of plugins are there that still has my proprietary algorithms that I am trying to work on. But apart from that, you can use this as much as you want. I'm going to export some of them. Some of them are exported as other source codes here that you can take a look at it. But apart from that, this is really a powerful tool. So it has built-in capability to visual programming, and I think this is one of the I have worked on TIPCO Business Works, and I have worked on other TIPCO Business Works, Ab Initio, and other tools, and they are pretty good at doing this. And I found this one to be more useful to developers who are working as in the code. So this basically you can use it as your automation tool or on your local machine, and you can extract the part and run it on there. I have used it as a process designer. I have used this as an integration tool. I use it for all many of my works. So I basically try to create the template of the things that I'm working out from the snippets and all, and I use this tool to do the visual programming wherever I need. To go over it, right, what all you can do. So at a high level, this is here you create designs. So you can go here and design the you know stuff that you want to design. For example, you can do a visual programming and design visual UIs, right? Visual components. You can do you can define diagrams in there, right? You can define CNC programs. You can design visual learning program. So this is a program how to how which I use for in my workshop. So overall this tool is not just one tool, it has many tools inside it. So I use it for my AI programming, I use it for my as annotation tool, I use it as visual graphics, I use it as integration tool, and I use it as my IDE. And to give you a brief overview of it. So basically at high level, things are built as a components, and I am a Java developer. So front end is not my strength. And, and I wanted it to be universal, the code should work even 20 years from now. So I built in Java and JavaScript. I don't have to worry about, Node and all things. And after 10 years, when I restarted the code, even then it works just fine. Right. So that was the strength of, programming it in the JavaScript. But overall, if you look at it, right, so what you do in here is you go here, uh, basically you can design your graphs, and there are different kinds of graphs and things that you can design. And to give you a strength of how many different types you can do it, you can define, you can build graphs over Java code. There are experiments on how we can do SQL mappings. There are basically graph programs that you can do for G code. This is for a machine. You can actually define a graph to run the GRBL in an order. You can define tag models. You can define a model for EV3 programming. For example, I will show you how I do EV3 programming and my robotics programming. There are some geometric algorithms that are available. So you can take your, let's say, design, and you want to triangulate it and see how it will work and do different, graphical analysis you can do here. There are mappers for shapes. There are shapes, shape pixelate, and shape offset and shape cavity. These are algorithms for working on these shapes. These are usually I use it for my G code generation or for my robotics need. So basically, if I want to take a shape and map it to something else or change the shape, then I use it. If I want to pixelate the shape, I use the pixelate. There are offset, there are cavity algorithms. There are also algorithms for cutting outside, cutting inside. Those are different algorithms to handle the G code. Then there are object mapping. So you can define object mapping as a hierarchically here, and then you can use it. You can define subgraphs. So you can take a graph as a subgraph and use here. You can define mapping at different label. It's not object mapping, it's just a data mapping that you can use. So you can, the difference between data mapping and object mapping is hierarchical. Data mapping is non-hierarchical and it's a flow. So it's basically a topologically sorted graph and acyclic DAG, right? While object mapping is just, it will have maybe two objects with some functions in between. Then there are web UI flow where you can design an entire web UI flow, compile it and run it, and it will run as a web UI flow in the application server. So one of these things in Cyrus 1 is there is an application, it's kind of an application server built in. There is a smaller version that I have open source, and I have a big version, and then I have a really, really big version where you can do BPM and other things. But in a smaller version, you can still run the web UI flow where you can define a web UI, how it will get the input, how it will be massaged, and how you will respond back. The template engine that it uses, its velocity. It's a pretty old code, so I didn't get a chance to move it up, but yeah, it works with velocity. There are UI flows that you can run. Basically, UI flow is something that you design here and run it. So this is used for real time running applications in there. But the idea is you define a your web UI flow here, you run it, and it will take run here. I will show some examples. Run automation is for my need for, it's recent. I had a version of it that I lost, so I built it recently. The way run automation works is you define a annotation of pages and things that you want to do. Then you run the automation on that, and that automates the basically whatever you want to do. Think of it as a RPA tool, but it's much more powerful than many of the RPA tools. Only thing is that this ID is not very user friendly because it's built for my use and my use only. But yeah, you can take a look at it. Compile to code is basically you can define a graph and then you can compile it to code. That is basically works with the Java objects that are defined, and I will go through it. So if you go to here design library, and there are plugins that bring their own design library. So design libraries are here. What you can do, for example, in a code block, I can go and define a Titan class. Titan class and Titan job right now doesn't work. That's not exported. Except for the Titan box, everything has to work. For example, I can define widgets. Widgets are something that are used for building UI and learning how you can quickly build it. For example, if I look at a continuous timer, that is basically there every second it will go and do something, right? So this is a timer I have added in my design, and what I do is this on. So what this timer is doing, every timer is selecting, and I can write different codes and modify the code on the timer. And the way it works is, okay. So the way these some of these components works is you compile it and give it. So um, we are going to talk about how those different objects work. But you can build an entire web application here, give it to the compiler. Compiler will output a different applications. And there are other things. For example, FLLMAT is there where you can use the FLLMAT to do the programming and create it. So for example, you can create a let's say this is like I'm showing you robotics. Right, so this is defines my robotic path. This is the coverage it's defining. So all I have to do is now Joe send mapper compile and then give it compile EV3 model. It will call a EV3 compiler in there, and the robot will go on that path, right? So that's built on the hierarchical complexities of the objects that you want to build. So there are similarly there are image filters. So design. So image filters are basically how to work with image filters. So these we have defined a lot of image filter, and what you do is once you have defined the image filter graph, for example, I want to take the image to do it some, let's say, some analysis, and I can connect the input output. Let's say connect ports. I connect this port with this port, compile the graph, and send it out for execution. What will happen in the end is uh, all I have to do is mapper compile and compile to my OpenCV or visualization pipeline or whatever pipeline it is, and it will compile it to that graph and it will be available. And what it does is there are many graphs that are executed interpretation. I believe more in compilations. So once let's say you compile that, the compiled mapped library will be available here to execute, and it generates pretty much code depending on what kind of uh, what kind of graph it is. So different graphs generate different kind of code. OpenCV will generate a different kind of code. So those are all generated here. Now going back, and these are like different types of for different needs. For example, if you have a visualization lead, so you can write a visualization here and then basically change like say visualization code, and this is used for this is I think is being used for input port to see the visualization. So there are different visualization. You can create the dashboard, save the dashboard, and then there is a dashboard viewer which you can use. So there are dashboards built in there, that is again for my use. So I built my uh, diagram. So this diagram I can go and edit the diagram in the source, and then I can change whatever I want once my visualization is done, and I can make a dynamic visualization. So this works well with the code, and then that visualization is here, and then there is a viewer. I think I forgot the what is how to run the viewer right now, but you just point to, I think the viewer is somewhere, its name is there is somewhere viewer. You just turn the viewer on here with some parameters off, so it basically runs as a viewer. So final dashboard what is built is shown. So there are dashboards in here, there are CNC generative, and this also has a generative model. So for example, let's say I take a CNC generative. Hmm, okay. So there are CNC generative which I use for cutting holes. For example, for my CNC machines, if I want to cut some hole, I tell I want to the drills to be holes. So number of counts, center axis, at what distance, at what angle I want to do. So it will drill holes on a line, and then basically there are different other types of this. And what I can do it is I can wire them, right? Once I wire them, I can basically define how it will do. Then all I have to do is mapper, design mapper, compile G code. So it will generate my G code. So I don't have to worry about this. Right now the parameters are not available, so it's erroring out. But once I configure it properly, it will generate the my G code. I will show you some examples of G code generation, how it works. Okay. Apart from so what is available? There are a lot of things that are available here. For example, there is annotation for a spring, so we can configure the spring graphs, and then there are spring graphs. This application itself has some graphs that it run at startup that you can change here. So think of this application, you can modify by modifying one of the diagrams. So at the start of that application, that basically executes that graph, and that graph is available here. You can export the graph as a JSON, and the utility there is a utility available that can run it. You can compile and build the jar right from here, and then run the jar too. So there are a lot of things available here. There is a freehand drawing available, so you can freehand draw things and do it here. If you want to design component, there is a component designer right built into here. I will show how to design a component. So all these components that you see here, right, image filters, these are all built here. These are not built outside. These are built right within the code, and there are some who are built like this is the component built. And what we do is there is a certain paradigm you need to follow, and then you can convert into the a component that can be used in the compilation. Okay, apart from that, for example, like this is defined right now. If I want to add, just to give you a glimpse of a component designer, you can go to, I think it is here in design library, not in design, should be available in widgets. I can do a output put, and I can drop here, and let's say I say PE. So it's available now as a output put. When I do here, it's available, and I can just save this component and it's there. And you can fully design how you want it to. your components to be. You can define complex mapping, complex ports. So different kind of ports are available that are available as drag and drop. And all you have to do is just save the design, go to your design, save static component, and this component is statically saved and then is available as a droppable to here. Then you can drop it and use it in different diagrams. Okay, so that is there. So all these components, most of these components are designed here. So there is, for component designers, there is no backend required. Everything is stored in database, everything you code here, everything you program here. There are widgets available for building monitoring dashboards. These are here. So they are used for basically seeing how the graphs are running. Uh, there are annotations available for these annotations, text, lang, and points. These are available for different things. These can be used, annotations can be used with different kinds of objects. The way the annotations works is I could say, I can add a annotation very easily. And what that annotation would do, it is basically it will, when the graph compiler is compiling the graph, right, at that time it will tell this is the annotation available for that object, and that can make a decisions. So you define annotations in the UI, and then the graph compiler, the default graph compiler cannot use annotation, then you will have to override the graph compiler and use that annotation to do something. For example, I can take a text and describe the text as, for example, if I look at text annotations, right? So there are text annotations to define the text. That is used for text analysis. Then there are annotations used for defining certain graph attributes. So you want to say, you want to finish first, finish last. Apart from that, there are at higher level objects like steps available. There are many other objects available. Okay, and some of the graphs you can compile it in Java or JavaScript at the same time, right? So there are camel plans, spring config, event mappers, and then mapper template that especially run on the server. Then you can run a template on the server. Then you can also execute a distributed graph and compile first graph and state machines. Those are experiments. The execute one, these two, these were just why I was looking at certain experimentation, but you can do that. To give you a overview of what kind of diagrams you can create, so these are some sample diagrams that I have already included. For example, uh, yeah, and I sometimes use it to code. So I will create uh, a new ID, a new design, and I will start coding. So this becomes part of the code, and then I can basically save this is my code in the same, and then in the same design, and then I can use the code to do certain things that I want to do. Certain times when I'm experimenting with the UI or experimenting with the run, I can do that, right? So once I save the graph here, all I have to do is mapper.compile and run on server. So once I run on server, it basically run this code on the server in a certain way. On the server side, most of the objects I export as a JavaScript object, so they are available in the JavaScript. So the same JavaScript that runs on the server, uh, I think for certain type of graphs, those objects are available. So what you run in UI, you can run it in UI to do things, and then you can run it in the backend too, as is. So let's see some more designs. So this is a design basically of how we can design the UI elements, right? So there is CNC programming here. So it basically generates for my CNC test. There is custom select and drop. So this is a example of, if I change the UI, it will change my design. Uh, right, these are CNC my lines. Train DRO. This is example of showing how we can train the DRO. This is example of DRO design. So basically AI program that annotates and learns the design. FLL, I think I showed you. There is a FLL, this is testing, which are showing two paths, and then it shows EV3 actions, right? Okay, and you can very easily go to script and define your own objects, define your how the objects are drawn in there, and they are available, and they will be start available here to run, right? So let's say this is there. Mm, this is again, showing how I can do my CNC one. Mhm. So this is the graph I was talking about, generated graph. So this basically generates the circles to be cut here, and then if I go mapper compile G code. I think there is an exception. I have to see. I know what is the exception. Okay, this is some of the code is pretty old. So that doesn't updates the object. For example, I think let's say this is there, this is there. I think it should work now. Design. It works now. So basically now I have the program ready to cut to generate, and I can generate it. Right, I can increase the radius, yes, 40, redraw, and then I say mapper compile run UI flow. So it will create now two circles that are there. Okay. Yeah, and basically, so think of it, this circle when I'm moving it, you will see it's changing. It's basically what it's doing, it's generating a program to cut two circles on my CNC machine. So I can do a generative program, and this program is written here, so I can change here, and I say okay, and then it will show up there, right? Redraw, and then I say mapper compile run UI flow. The circle is there. Okay. What else we can do here? Okay. Uh, so that is one. There are some inbuilt groups. So basically, this is how these objects are grouped here. So this is internally that is used by the application to basically organize these objects. So if you take something and drop on the group and then save the design, then what will happen is here that will grouping will happen. You see this menu. This is be run by this chart groups. So as I said, many things in this are being run by in there. Let's see if there is a Java example available. Yeah, so this is a Java example code that basically uh, compiles a Java code in a certain way and runs it. And there a lot of these codes are, big again. So this is designed here. And a lot of these things are designed within the system itself. Right. Let's see. There is a automator. So this is a automation graph, and then there is a, I think I was experimenting with some drawings. They are available here. Then okay, we'll go over it why it's doing like that. It's by design. Let's say if I see Chrome 2, so this is a graph to test the Chrome application. Then you can do annotations. So this is basically these are the annotations available. You can define the hierarchical relationship in the annotations, and I will tell you what are these visual annotations used for little later. So let's see some graph library. Okay, so design, new design. So there are graphs. Graphs used to be design, open design. Let's see if I have any Saracen. Mm, So this has a lot of tools for handling the SVGA, handling a lot of things. So, for example, I say, um, yeah, and at high level, right? Whatever objects, for example, let's say if I want to go here and see how this web page involved, if there was any history of this design, so I can go to historical window, show historical, load the historical values. There is no history, so there was only one graph available. But if I take, let's say, something that has a available design, let's say Chrome 2. Right, so this is my there. I want to find out how it evolved. So this will tell me all the versions of Chrome 2 that ever existed. We record all the versions of it, and then I can go and select the version. So version 1 was like this, it evolved like this. So we have the entire history of how the graph evolved and what is there. And you can go to any version, save that version, and that version will become ready from there. But it will still become the version 0. So if I go back in history and save this, and then that will become the latest version. Right. Apart from that, it has a lot of so there is a inbuilt routing engine in the web application that runs it. We can start, stop, control it, reroute the engine that is used basically for integrations. There is right, a lot of things can be done freehand. For example, I can create a freehand layer, right? So this layer you can see, and I can see the layer and other things. It has a built-in support for shapes. So shapes actually existed in different forms, and shapes are used for a lot of things. For example, annotation, like I showed you DRO, right? So you can take the annotation and start using it for any other purpose, but that's how shapes are used. So if I create a new face shape, and then you can create a 3D shape, and let's say I create a shape and I go stop, create point. So this is a shape created which I can move, and I can also shape, I can pull up and then build a 3D shape out of it, and then I can do different stuff with the shape, and I can define as many shapes as I want. Okay, so I create new shape sh2, right? Oh, I'm still in pull up mode, so I can say pull up off, and then I can move it, right? So I can move the shapes around and do it. 3D shapes are not much useful because the angle translation is not really that accurate. Let's say nearest and new design, but that's how basic of the shape is. You can also uh, you know change the shape. You can do a lot with the shape. Similarly, animations are used to define animation points and compile it. I think the plugin for this is not working fine. I think something happens. You cannot do recent action, shows what all recent action is. Design allows you to save, update item, delete designs, and update item. For example, certain times you will update the component that you built here. You want to do it, you can do update item. Here, mapper is basically used to compile it. There are tons of map graphs available here. I will show you. Routing engine I showed, window is about all the windows available. There are a lot of windows available. So I can go to processor library. I can create a new processors. We don't use processors much now. I don't use much now. There is a library window where I can see, sorry. There is a component config window which will show you what all component configurations are available. Certain libraries use component config window. There's a file drop box. You can drop the file and it goes to the server. Uh, you can have the command window where you can run the command here on the server. So the server basically means this running. Um, then there is a window for droppables. So these are the droppables available. Droppables are similar to what you see here, but it's just in a nice concise way. So it has a list of all the droppables that are available. So these many components are available, and it's like huge. I think there are some 700 components available in the component that basically will take care of anything from Excel mapping to literally everything, right? And the mappers are hierarchical in nature, so that's a very high tech. Let's go to Windows libraries. Dropbox is web pages. You can define a new page, and the page is basically you define page processor. I will come to web page. How you define a web? I define a web page here and use it. I use it sometimes to build, small sites on there. The way I run it is this whole server has a server version that runs on one of my big boxes down in my basement. And what I do is I build the application and then I just deploy these applications here. The application is nothing but, whatever I build here is there. So I don't maintain any other platform. I just maintain this and it takes care of all my integration works. And it runs faster than anything possible customization because it compiles codes and run it. It writes really optimized code, right? So if you look at the way it generates code, it does is a pretty good niche stuff. And it has a very complex graphs. So it's not like it will generate one-to-one Java code or you will define one-to-one Java code. You can define really, really crazy ways of building the code. And I think in the other, I will do it. And then there are certain things you can download the design. So if you click on download the design, you can define the JSON that you can do it. There were other options available. Export, you can download the PDF as image. I don't think it works right now because that needs a PDF exporting something like Selenium or some other ID. Selenium was not there at the time. I think I used to use, uh, there is a wrapper around headless Chrome. We used to use a couple of them. You can do it. And then these are used for, I will show you. And then the connection, right? So, you know, let's go to new design. I think this will not, these are all the windows open. So let me take care of something. So let's go to new design. Let me show you certain graphs. So these are different designs. There was a older topology, older way of doing it about 15 years ago, less than 15 years ago. Uh, there what I was to do is we used to define graphs. So you can define graph. For example, this is I think I lost the graphs. Okay. So I will show you what does a graph basically mean. So these are designs and there used to be an old thing which is called as graph. Right. So let's say I start with a new graph and then what I can do it is, yeah, and it supports two kind of context menus. One is this you can use, and then there is a custom menu which you press control and run it. It also has something called basically it listens to your mouse and keyboard and it has I forgot what it is called. It's called basically how you are swiping or how your mouse is moving. Based on that, it brings the different things. So, and you can define events here. So, yeah. So, what all support it has? So, the plugins that are written here, I think plugin is basically you go here and you can upload a plugin. I think there is somewhere here a load plugin. Install plugin window. Or I think you just drag and drop. I forgot export. Somewhere there is a plugin option here where you can load the plugin and install it. So we have plugins. I have plugins built for Lucene. So how to index data, how to process Excel, PDF. There are, I think I have built OpenCV, AI, robotic process automation. I have my somewhere around 20-25 plugins built in, which you can just install it, and those plugins make things available here in the plugin menu. And then you can plugins can define at different points what all menus are available, and they will come over there. Okay. So the basic idea of a these are the graph and compass that you do, which are basically different things, and then there is a integration graphs you define. The way integration graphs you define it, you would define a event. So you can either define an existing event. So there are already events defined. There are actually hundreds of event defined, and you can define a new event. For example, let's say trace event. So this is basically a trace event that is defined here. If you look at the trace event property, uh, yeah, so I will go to the property little later. The benefit of the trace event is, defining the events is once you define the object event here in the UI, The benefit of that is the framework takes care of how that object is compiled, uh, converts, provides generates a lot of code for that event. So how that event will be saved, how that event will be indexed into database. So it generates a lot of code around that event, importing, exporting, converting into JSON, and all that is near handwritten code. So it runs there and really as fast as you will code. So there is an event you can define, then there is something called as a stream you define. And the stream is basically, let's say I define my stream as stream one. You define this stream will handle what kind of event, and then you also define what is the processes that's there. And there are some extra configuration and exception stream. So if stream has an exception where it should go, and if there is something extra, you define a stream. You then define a processors, right? For example, you can nodes. So node is basically a who is going to process this, and we have hundreds of node available. I think I have 600 nodes available that can basically take care. A node would listen to this stream. I will show you. Let's say node one, right? And then you define the query also. So you define a node, and then you go to stream and click on the stream. Um, right, and then you go to stream, then you choose what is the processor. So basically now this stream is connected to this node, will process this event type. And what this node does is, if you click here, it will tell you this node is basically going to do is, let's say you want to async db processor. So whenever a object comes on this stream, it will go and send it to this node event. The event type that you handle will be trace event, and then you can go and look into your code what is the trace event, and you can define some of these events are defined as a code, right? And then they are loaded in the object. Some of the events are basically can be totally built in the UI. I will come to that, how to build that completely in UI. Then in the stream, I think in the node you did, then you define stream modify stream, and then you can add a stream property. What the stream properties, so streams, yeah, let's come to the stream property. When you define a stream, right, stream has not defined a property. So this is mostly streams are used for defining flat objects, and you can define a complex object too, like a string. You can take it and then process the stream. For example, if you're listening from Kafka, you can just define a string property, take it, give it to a processor that will basically convert that string to a given format, and that processor you can configure and then pass it to different streams. So that's what how these streams work. But if you want to do really fast processing of these streams, then you can go here, add a stream property, and in the stream property you will be basically uh, defining whether what type of property it is, string, integer, boolean, and automatically entire thing for that stream processing handling will be developed, right? So when this stream is deployed, the processor will take care of generating the code to listen to it, and then you can define XML expression, a lot of stuff for that stream. Similarly, for the event, you can define add event property. An event property, again, you can define like this is the event, what all properties are there. You can start with a new event. You can create event, add a new event, and then you can keep adding the event. Once you save the event, automatically all the generated code will go to the server. You don't have to go and do anything. Similarly, if you go to the and I will tell you a really hierarchical events how can build. So this is like a simple stream processing. Simple is, it's not simple stream processing. It supports complex event processing, and it supports different kind of engines also to process. So let me just quickly draw another stream. Let's say stream 2, and then it will again process. Let's say node 2. I will say node 1. So right now this is another stream, and then I will add a node, add node, and node. Let's say 2. That's there, and then I will go and modify this stream, and then I will say it will go to node 2. So now this stream is connected. Then also I can connect these streams. So freehand, then I can create connection. So there are different ways of connection. I can add a connection and say CO, and then I can tell from stream 1 to stream 2, right? And then the conditional connection. So there are different connection types available too. So there is available for camel type. There is a so these So basically, what is a connection handler? What connection does is, before a object is passed from one stream to another stream, they go through a condition connection handlers. These connection handlers basically have their own properties that are defined, and which are defined basically in forms of condition here, right? And what they will do is they will take that condition, and based on that condition will work. I will go into the second part and will show in the second part how to define a connection.